are these measurements and why do we do this? What we have here that each of you have is a copy of the Santa Clara River Watershed Assessment. This is a report put out on dealing with management of the Santa Clara River. It's broken up into two sections, a north and a southern section. And this is an analysis that was used to determine how do we manage this river. So what I'm going to ask you to do is you're going to take this report and you're going to take the handout for our lab. On the back of the handout, there are some analysis and interpretation questions. So you're going to, with your group, break these into parts. You're going to work as a team. So at this time, if you could turn around, form groups of 4 or 6, introduce yourself, and discuss these things and take some notes. We'll give you a couple of minutes to do that, and then we're going to turn around and have a discussion. All right, go ahead.
The natural things are not supposed to be in the water that are affecting it in a negative way.
Well,
be natural. Yeah, they're also going to be natural.
Really surprised too of how close it is to the home.
right.
And we let it happen. It's right next to the ocean.
Way higher than
Where the river flows into the ocean.
So I don't know if you look in, but it's all right. Last time, what is it?
So they know what their consequences are? Yeah, I think that's a...
Okay, so what we're now going to do is we're going to discuss your answers to our analysis and interpretation section. Let's start with number 1. It's a real basic question. And we got this out of our report, didn't we? So just for background, about how long is the Santa Clara River? It's about 100 miles long. Okay, good. And where does it come from? Where does it originate? Okay. And then where does it go into the ocean? This is a tough one.
It goes into the ocean because it is also an
Right? And that's where we just were, isn't it? That's the river where we just were. So that's a little bit of background. Okay, next question, number 2, is pretty much going over vocabulary. Any area has vocabulary. We have to understand the vocabulary so we can communicate about that area. The first one says, what is a point source pollutant or pollution? What does point source mean? So who's going to answer that one for us?
It's a single allocation source that charges pollution into the environment.
Okay? And today, we're going to talk about the fact that that's what a wastewater treatment plant is. It is a point source. Next one, what is a non-point source? Yes?
A non-point source pollution is a large or dispersed area, releases pollutants over a large area.
Great. And the textbook example of that is agriculture. And so we're going to look at that issue too. And it turns out our 2 big problems in Ventura County are our wastewater treatment plants, which empty into our rivers or our creeks, and our agriculture. So each of those significant problems is one of these types of examples. Next thing's talking about total maximum daily load. It's abbreviated in the literature as TMDL.
Total maximum daily load, or TMDL, is a regulatory term in the U.S. Clean Water Act. It describes the value of the maximum amount of pollutant that a body of water can receive while still meeting water quality standards.
Great. Question number 6. We have already discussed that agriculture is a big, as the question says, a big non-point source of pollution. Can someone give us some other things?
2 examples of non-point source pollution of Santa Clara River is storm water runoff, agricultural runoff, residential runoff, and highway runoff, aerial deposition.
So we have residential, we've got the street, we've got the Walmart parking lot. There are many different places that we get this type of pollution. So I wanted to emphasize that number 6 is a real big problem. Non-point pollution is a real big problem. Okay, so that's number 6. If we look at number 7, could somebody answer that for us, number 7?
The largest, most significant point source discharge to the Santa Clara River is going to be the water reclamation plant in Ventura.
Okay, so again, that's our wastewater plant. This is a huge impact, and as we learned before, ammonia, nitrite, and nitrate, those are fertilizers. So we're discharging from our water treatment plant into the Santa Clara estuary fertilizer. What color was the water down there today?
Green.
Why? Well, what did we put in it?
Algae.
We put fertilizer in it. And what did that make the algae do? It's exploded. Great. Okay, so that's the idea. All right, so now the bottom line is at the end, one of the big parts of environmental science, our last 2 questions, is we've talked about the what, a little bit about the why. Now we're going to talk about so what. How are we going to fix this? We can see that a lot of the problems are you and I. The city of Ventura, it's our wastewater. Everybody that lives there, we're causing the problem. So how are we going to deal with that? We need food. So we need agriculture. We want our food to be inexpensive. So again, we could blame the farmer, but again, are we all the problem? Yeah, we are. So we're going to look at 10 and 11 now. So the question says, what are some ways we could reduce agricultural runoff? How could we reduce the runoff? What could we do?
You can just contain it.
Okay, we could keep it somewhere, great. And then what's another idea?
They're both like one and the same. So you contain it first, and when you contain it, you can treat it.
Okay, now, these are great ideas, but are those things free?
No.
And if we do those, what's going to happen to the price of our food?
Go up.
So again, we can see now we're going on to another level of implication. Great, thank you very much. All right, let's go down to number 11. How would we deal with reducing the effluent from the wastewater treatment plant? How could we do that?
You can change discharge status to become restricted and treat water to a cleaner level.
Okay, so again, we can make the levels of discharge more stringent. And is that free? No. And we could treat it more thoroughly. And we could do this, and we could solve the problem that way, but again, it comes back to economics, doesn't it? And that's a big part of this class.
Water pollution may not always be intentional. It could also come through just negligence or someone not understanding the repercussions of not caring for water. It can also be polluted through natural processes as well, like runoff.
Exactly. Okay, well, I want to thank you for being here tonight, and we will continue next week, and I'll see you next time. Thank you very much.